Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead, CEO of SEL, and your host for Schweitzer Drive. Today, I've got Dale Peterson as our podcast guest. For 20 years, Dale has been on the leading/bleeding edge, helping security-conscious asset owners effectively and efficiently manage risk to their critical assets. He has pioneered numerous ICS security tools and techniques, such as the first intrusion detection signature for ICS that are now in every commercial product. In 2007, Dale created the S4 events to showcase the best offensive and defensive work in ICS security and build a community. S4 is now the largest, most advanced ICS event in the world. Dale is constantly pushing and prodding the ICS community to move faster and get better. I've known Dale for at least 15 years through his and SEL's cyber activities and interactions. While I don't always agree with Dale's positions, I have a lot of respect for his work in ICS cybersecurity, and that's why I'm so excited to have Dale on Schweitzer Drive. Welcome, Dale.
Thanks a lot.
All right. Before we jump into the nitty-gritty, let's give the folks a little bit on your background. Would you tell us a bit about your background and what led you to a career in cybersecurity, out of all the things you could have done?
Well, Dave, it's like a lot of things. I kind of stumbled upon it and liked it. So I was in college. I started as an engineer. I loved the physics and math and couldn't stay awake in my electrical engineering classes. So probably not a good candidate to work at your place. So I switched to business, but kind of that math, computer science, business thing had me going to be an actuary, which wasn't terribly exciting to me. So I was looking for something else. I went to the placement office to take a test to be in the diplomatic corps because it seemed like a pretty cool test. And they said I was too late. Like a lot of my college time, I didn't really pay enough attention. So they handed me this test. They said, well, there's this other government agency coming, the National Security Agency. You could take their test. And I had never heard of it. This was back in 1984, where no one really knew of NSA. It was just after the Bamford book came out. So I took the test. It was really a great test. It had these tests where, like a spatial test, where you would try to determine which two parts fit together. And I did really bad at that test. And they had a part where you would translate this actual fictionally made up language to see if you'd be a good translator. I did okay on that, but on the cryptanalysis part, I scored really high. And so I got an offer to be a cryptanalyst at the NSA, which was, I guess, quite a disappointment to my dad at the time, because he said, well, there's no future in security. You can go work at NSA, but what are you going to do after that? So I just got lucky. You know, I would like to say it was some great plan, but I just stumbled into it and have just kind of moved to whatever I've enjoyed in the security field.
How did you go from being a crypt analyst into specifically ICS? Because it was kind of, for a while, ICS was kind of obscure little networks. Nobody gave them much attention until a few people got the bright idea. You hear about stucknets and all that other stuff where, oh crap, we got to really worry about ICS systems from a cyber perspective.
Well, my dad was kind of right that when I left NSA in 1990, there wasn't much opportunity. So I did a little work in military comms, which I didn't enjoy too much, selling military gear around the world. And then I moved into banking and did banking security for most of the 90s. But when I started my own firm and we were doing some consulting to pay the bills, I got this water utility in Arizona contacted my little company in IBM, I guess because we had a good website or performed well on search engines. And they said, could you do an assessment of our SCADA system? And I gave the answer that most consultants give. I just said, sure, even though I had no idea what it was. And I'm very thankful it was slow moving water and not electricity, because the mistakes that I made early on were not resulting in catastrophe. So I just stumbled into it. But I'll tell you, once I went out and saw this was actually a canal moving water. Once I saw the pump stations and these computers, and it wasn't a data center in a bank, I was hooked. I just loved seeing these automation systems and what they could do. And the fact that they had no security just said, well, this is a greenfield. So I just started pursuing work in that area.
Hey, was one of your first mistakes you just did like a port scan on the entire network to see what would happen, or?
No, not so much that. We ran this tool called EtherCap on their switch that let us essentially man in the middle all the communications, and they had an old switch, and the switch crashed.
Oh no!
But I was so lucky with this customer because they could go literally 2 days without their control system. So they're like, okay, let's reboot it. That's cool. And so I was very fortunate again that my first experience was on something with such low consequence.
I guess depending on what industry, real time is, particular to everybody's industry, right?
Exactly.
Over the past couple of decades, you've been focused on cybersecurity for industrial control system in just about every sector: oil and gas, electric, water, manufacturing, mining, building automation. Now there's IoT and Industry 4.0. How has the threat landscape changed, and what are you seeing now that perhaps you didn't see 15 years ago?
Wow. Well, I'd probably point out a couple of things. One is the idea that people don't understand they can attack these things and don't have the knowledge to attack these things has largely gone away. So now, maybe 10, 15 years ago, it was still a mystery that, there were people talking that you could attack these things, but actually the leaders that would order the attacks, or the the crime entities that might do the attack, they didn't really believe it. But now it's been proven enough. So now we have people that actually will go after these things. So I think in that sense, the threat has really increased. But probably the more troubling area is that the independence of these systems is no longer there. And I don't know that we can really fight this, but the fact that you might have something related to the control system that will go down, that will affect your ability to deliver your product or service to your customer. And a Colonial Pipeline is the prime example that everyone uses for that. The actual control system was not affected. So this interconnection that some people call convergence, I don't really like that term, but this idea that we now are reliant on this technology to a much greater extent that we don't really have control of, I think has increased the risk to these systems.
Yeah, I tend to agree with you. I think, say, 15 years ago, maybe a little bit longer, we've always had control systems, but you could probably make an argument they were air-gapped, though nothing is ever air-gapped, and they can kind of run independent of the IT systems, and they were really special purpose control systems. These days, as you pointed out, is there's such speed for integration or convergence, to use a word perhaps you don't like as much, but this one, we recognize it, but at the same time, we're trying to converge all of this stuff. And, I've heard people describe, hey, let's put our control systems up in the AWS cloud and run it from there. And wouldn't that be a great thing? Maybe they're forward thinking. Maybe I'm old and I'm not quite there yet, right? But with the speed with which all this integration, and I think the various different attack surfaces that happen is certainly different than it was 15 years ago or so.
Well, there might be like two spins on that. The one is that we had 15 years ago more people that understood how the system worked, that didn't, they could operate it without the technology. Yeah. And a lot of those people have retired, or they weren't the people that built it originally, so they never really learned it. And they only know how to use it if the underlying OT technology is there to help them do it. So I think that's one part of it. The other part is that we just don't have as many people. I mean, the better we get at this, the less people we have to actually step in, even if they had the knowledge to do it. So we don't have that workforce. But we have it's not new. We saw it in the 90s, actually, but we have this bad tendency to bring in technology without bringing in the total cost of ownership of that technology. So we saw in the 90s when people were deploying Windows for the first time, and they would deploy something like Active Directory, and they would have no domain admins.
Yeah.
They just dump the technology in without this concept of cyber maintenance. And we're seeing more and more of that now with, virtualization infrastructures, complex switching infrastructures. And the more you do that, the more you run into this fragility that's a little bit scary.
Yeah, maybe to go back, I look at the internet, if you will, before Al Gore invented it, or after he did, I guess, is that it was built on an assumption of trust. And then we realized it wasn't just a bunch of professors, sending around, papers or something like that. Rather, we want to use it for all kinds of different activities, and they're not nice people necessarily on the internet. Same thing with the control systems. We built these things to do a particular function, not necessarily with the idea that, hey, somebody might want to track or hack into these systems and use them for perhaps purposes they weren't designed for. So there's some challenges there. So that gets me to my question then. Do you think our control systems are getting more secure or less secure? And what would be driving the answer you give?
Well, progress does not move as fast as I'd like. I'm pretty good at predicting. I'd spend most of my time now doing analysis, whether it's in the content I produce or as part of my event. I'm pretty good directionally, but in terms of timelines, I'm not as good. And things always move much slower than I hope for and what I predict. And so that's troubling, but it would be hard to argue that we're not more secure than we were 15 years ago. And 15 years ago, the number of asset owners that now have a security perimeter as compared to 15 years ago has greatly increased. The number that are doing secure remote access has greatly increased. The number that have backup and recovery capabilities has increased. So we are certainly more secure in the sense of we have more security controls and they are doing a better job. I would say, though, that the risk has probably increased just because of, again, the increased threat, the increased level of, I would say, the increased potential damage of an attack and our ability to respond to attack maybe being decreased. So we're doing better in security. The problem is that the threat and the consequence of an attack has gone up faster than our security controls have reduced risk.
Yeah.
So, it just depends which way you look at it. I don't feel like we're safer now, or we have less risk now than we did 15 years ago.
Are we worse off now? If we're not safer, are we worse? Yeah.
Yeah. From a risk perspective, I think we're definitely worse off now.
Is there light at the end of the tunnel?
Well, I'd like to think so. I have some fundamental issues. You say you and I don't always agree. I don't know if we agree on this. I know I disagree with CISA in the U.S. on this. I find it extremely troubling that we continue to not address the core problem that so much of these systems lack authentication, that access equals compromise. I know some of your products have that capability in them, but when you look at the deployed base, that's just a massive problem. So everything else we do is like trying to put a Band-Aid on this big gaping hole that we're not willing to close. And until we step up and say we are going to get rid of this insecure by design, it's hard for me to be optimistic that we're actually going to solve this problem. The other thing that I guess I get a little frustrated at is there's only so many resources, and I see us expending a lot of resources and as a community doing a lot of things that maybe don't really address risk. They might address good security practice, but they don't address risk. I'm hoping we can get over that, but that would be why I'm not optimistic.
Well, I think I am kind of optimistic when it comes back to authentication. We mentioned trust earlier in the podcast, and I think fundamentally that's what everything comes down to is this trust, whether it's initial trust or after we've established some trust, maintaining that trust. So when it comes to authentication and stuff like that, we've got a lot of new products that are coming out with all of that stuff in there. You mentioned the ICS, the systems we build get stood up and keep running for 20 years, right? So going back, and that's our biggest challenge, right? Is legacy systems, I think. Going forward, it's probably a lot easier to make things cyber secure, but certainly we've got a lot of work to do with legacy systems that are installed. And the part, I'm a controls guy by training, so it's like, man, I designed the system, it's doing exactly what it should be doing, it's doing great. Why mess with the thing other than it's got some cybersecurity challenges on the back end we need to go address. So that it's the economics, it's the people, how do we deploy stuff, that these systems are all over the place. It's a monumental task for all of us.
It is. And one of the challenges, though, I think, is to step up and say we're going to address it. I've been hearing now for 20 years that it's going to take decades. If we had actually said, we're going to put in a stake in the ground that every asset owner needs a plan to upgrade or replace their system. I'm not saying do it tomorrow, but what, executive, what is your plan to address this? And the government's, come out and say, you actually need a plan to address this. It's not acceptable that it be there for another 20 or 30 years. I think until we actually step forward and say we are going to address it, it's going to be difficult to really make serious progress on this. We're just trying to avoid catastrophe, I think.
And this probably maybe goes back to there's a lot of activity going on. It may not make us safer. In the electric sector, we certainly have our NERC SIP standards, right, which tries to, a lot of controls and mechanisms and procedures and policies to get put in place because of that stuff. I'm not as familiar with, say, the water sectors or other sectors on what they have in place. And again, that cyber stuff is really at the higher voltages, right? The bulk electric power system, not necessarily down at distribution systems or what have you.
But I think a lot of your stuff, a lot of SEL stuff is kind of the philosophy that the other sectors need to look at, especially if we're not able with high confidence to prevent attack. Then we have to start to say, how can we prevent a successful attack from being a catastrophe? And this is where you start to look at protection and safety systems that are unhackable. Unhackable not because they write their code so well, but just because that capability is not present in the system, like a pressure relief, like a physical pressure relief valve. And I think once the other industries start to look at that, they might find the way forward. If you look at the Oldsmar attack, for example, the Oldsmar was water utility in Florida with really terrible security, and they got in and got to an HMI and tried to dump a lot of a chemical in that could have caused people damage. But it would have taken 48 hours for that water to flow through, and there were all these manual checks and other automated checks that it just was not going to happen no matter how bad the automation system was, the ICS was, or how good the attacker was. And I think the electric sector has always kind of been on the forward edge of that because things can happen so fast that you have to prevent those from happening. And I think that mindset needs to grow more in the other industry sectors. Yeah,
the other thing is nobody ever says anything about the electric sector when you walk into the room and the lights come on. But when we have a bad day, everybody knows about it right away. So there's a lot of public visibility when we mess up.
Yes, definitely.
Dale, you and your team at Digital Bond have done and shared a lot of great research around ICS security, including developing the world's first set of ICS intrusion detection signatures. And these have been integrated into almost all commercial and open source ICS systems. Project Redpoint code enumerated ICS and OT components, and those have been integrated into Shodan and most vulnerability scanners. And Project Basecamp shined a spotlight on the insecure by design problem. And I want to come back to that in just a second in PLCs and RTU controllers, and led to the development of the next generation of more secure products. Let's tangent for a second. That define for me, help me out, the insecure by design and what exactly you mean by that.
That came up with our Project Basecamp because what we found with so many of the PLCs is that you didn't need to find a bug or something to exploit in the system, that what the attacker would want was a documented feature or function. So, for example, if you can upload new firmware or upload new logic without any authentication, well, there's no reason to hack the device to change the way the device operates, because that's a feature. You just look at the manual or look at the protocol spec and follow the instructions, and the attacker can do what he wants. So we called that insecure by design, because the insecurity, the thing the attacker would want, was designed to work the way the attacker would want it.
Yeah, that's the way I read that, insecure by design. It's like, no, I intentionally designed it to be insecure. And rather, I think what it is, it was designed without any cybersecurity requirements in place at the time. I've often heard is like, well, Modbus, I can attack a device sending a Modbus. Well, you're just using the protocol. That's not really an attack.
Yeah.
Okay.
So it's you could say designed without security. Maybe we just for the marketing hype, like the insecure by design. It's the same sort of thing. The insecurity was, or lack of security was designed in. It's not a flaw. It's not something the product is doing that it didn't mean to do. It's operating exactly as designed.
Well, your marketing worked, because it got me thinking. So good job on that one. Well, given all that, what kinds of research or other areas of interest are you guys working on or really excited about these days?
Well, this is a much happier topic. I feel like the former was all doom and gloom. So this is actually what I spend a lot of my time on, because S4 is very future focused. So I am always looking at what is new. Well, our tagline is create the future. So I don't do a lot of research anymore. I used to have a team of about 10 to 15 people that did research. We stopped doing that maybe 7, 8 years ago, but I'm always looking at what is bleeding edge out there. Mm-hmm. And I would say there's two, and then there's one that isn't research, but I think is really important. The two that I'm really kind of really looking for talks on and really interested in learning more. One is very applicable to SEL, and that is endpoint detection and response at level 1. So we have all these systems that run on computers that are identifying when something is attacking it, whether it be application whitelisting, antivirus, a variety of other techniques. Where is that technology in the level 1 device, the PLC, the RTU,
and just for our listeners, right? That you're talking about the 5 or 6 layers, where layer 0 is like the sensor, the actuator. Level 1 is like the first level device that's connected to the actuator or sensor.
Right.
Yeah.
I mean, it's most commonly called PLCs, but you have SEL has a number of level 1 devices that wouldn't strictly be called a PLC. And by that, I'm not saying that we necessarily have to mimic, although we should learn what was done at level 2 on the computers and the workstations and servers. But I've seen, for example, some research where people are saying when logic is loaded to the PLC, we're going to pull that logic apart and look for attack code in that logic, just in case someone has compromised the engineering workstation. So they have the ability, even if authorized, to load logic onto that PLC. How can we pull it apart and look at it? So I think that's a fascinating area. I've seen, I think we had 2 or 3 talks on that this year, and I think it's something that's going to increase. But, that's bleeding edge stuff. You're probably not going to really see that widely deployed for a couple of years. You want to hear the other area, or do you want to talk about that?
Well, I was just going to say, we thought about that too here at SEL. One of the things we do, and I don't know if it fits into exactly what you're saying is, but for all our devices, say out in a substation, I can pull the settings that are running in those things and then compare them, to a known good version of what I think is supposed to be in there, and we can sign both sides of that thing. So I know that there's nobody in the middle getting interfering with that. So that's kind of a check we do all the time for our devices in the substation.
Yeah, and I think that's extremely important to actually digitally sign what's loaded up into the system and authenticate it, not only when it's loaded, but also then we're seeing some of the devices actually have runtime protection. So they'll actually periodically validate it. But if you're in if you've compromised the engineering workstation, and if you look at most of the attacks that have been widely publicized, Triton, Stuxnet, the Ukraine attack, whatever, they actually got into the engineering workstation, in which case, if they modify it there, all these authentication checks aren't going to detect it. So this is kind of that next area. And I think it's really cool, but again, futuristic. I would imagine you guys will look at it because you're pretty much on the bleeding edge of this sort of thing.
So let's do this, and this will be. I don't think it's controversial, but we can have some fun talking about it. What are your thoughts on bills of material, particularly S-bombs?
I'm not. Of course, they're a good thing. So here's where we get into this concept of, is it what we should be focused on? So there's so many things that we can do that we say, yes, that is a good thing. Yes, that will improve to a certain degree, but how much of a real difference will it make? And right now, with S-bombs, most of what I think the difference it'll make is that it will tell you whether your vendor has control of their development process. So I would almost use it. I would recommend to asset owners that they use it in their RFPs and say, do you have an S-bomb? Like we used to ask, do you have a security development life cycle? Okay, that's great. Show it to me. Show me the artifact. Show me that you actually did some fuzz testing. Let me see the results. Oh, you can't show me that? I don't believe you.
Yeah.
Same thing with the S-bomb. Do you have an S-bomb? Do you have it? And are there 10-year-old components on it? Okay, well, that means you're maybe not keeping your product as modern. But beyond that, I don't see a whole lot of value for probably 90 to 95% of the assets inside the OT zone.
That was kind of my thinking. I come up with an S-bomb. I give it to an asset. What do they really do with it at the end of the day? Are they going to go through all the libraries or the modules or what have you? And we're going to do them. No, I'm getting forced to do them, so we're going to create them, kind of thing. But I don't know how much value they're really going to add to the asset owner.
Well, and as a vendor, I would imagine now you might not have had them in the Cyclone DX or whatever format, the SPX, SPDX, I can never remember, but whatever format they're saying. But I would be worried if a vendor didn't know what was in their product. So, and knowing SEL, I'm sure you had that documented somewhere. You just weren't providing it in this industry standard format.
Yeah, and that's true.
Again, not a bad thing. I can't say there's anything wrong with it, but would I recommend that asset owners spend a lot of time maintaining their full list of S-bombs for all their cyber assets in their OT zone? I don't see a lot of risk reduction achieved for that level of effort.
All right, that was a fun tangent. Hey, back to the research. Is there something? And this could go across all ICS industries. Some area where we're just not focusing that to you is just a big gaping hole in ICS security that is just being overlooked or taken for granted, or really should have some focus on it.
Well, the other area, let me just mention quickly. The other area I'm excited about is process variable anomaly detection.
And what's that?
That's where you look at your physical process and you can use machine learning algorithms, whether structured or unstructured data, and you can actually say the physical process cannot operate like this. So the data is wrong somewhere. So GE did this with their digital ghost, where they actually looked at their turbines and they said, we're getting all this data from our turbines. We're looking at it in the digital twin. This value doesn't make sense. It's wrong. That sensor's wrong or something like that. As we develop these digital twins, I'm excited about that from a research standpoint. But to answer your question, the area where we need to spend a lot more time on, I think, is orchestration. This idea of building up and tearing down these systems very quickly using orchestration, because that can really allow us to make changes with much less impact, recover much more quickly. You said the cloud early on. Well, what if you had, let's say, a couple of your environments in the cloud and they could be rebuilt real quickly, and you had one on site, and then you could switch between the two of those almost immediately. I think that people need to be spending a lot more time on making the recovery extremely fast through orchestration.
I'm with you. It's, internally we have discussions about, hey, designing to be secure so we don't end up on the design by insecurity list, right? So designing, I think that's one thing, but I think we're all old enough and smart enough to recognize that we're never going to build it 100% correct. There's always going to be problems. So I like to pivot and say, okay, designed to be secure, but at the end of the day, something's going to happen. So how do we recover as quickly as possible, right? How do we live in an environment where we can get systems back up and running if they're compromised?
Well, and what if a bunch of this SEL equipment was all virtualized except for the IO? So that if something went down, you just move over to another virtual instant of it, yeah. and you just run there. I mean, without, maybe the person doesn't even see it. And so that even without cyber attack, that increases our reliability to a great degree. I mean, this is like so many things. This is just copying what's going on, in the in the IT world, but it's the benefits to our world in some sense are almost greater than what they saw in IT. In IT, a lot of it is cost-based, but reliability for us, the wins there can just be huge. And I think if I was an asset owner, I'd be looking at how can I reduce my recovery time? How can I lower my recovery time objective and the cost related to that?
Yeah, and there's some work certainly we're doing, and I bet others are too. In the network world, we're big fans of software-defined networking, so we can abstract the hardware from the configuration of the flows, which is I think tremendous. If you said put $100 down on a new technology that you'll see in ICS systems all over the place 5 years from now, that SDN is what I do from the networking side. When it comes to some of the protection and control stuff we're doing, there's a what they call is centralized protection in our industry. And basically that's taking a whole bunch of different individual boxes, virtualizing them onto one machine and doing a whole bunch of different protections. And then just to your point, having sensors out inside the substation to open and close circuit breakers or measure currents and stuff like that. So there is work going on for, in that I'll call it that virtualization. And whether it's running on a box inside the substation or it's running somewhere else wouldn't matter.
Yeah, I'm with you on the SDN. In fact, we selected Tim Watkins from SEL to teach that this year with the training we did at S4. He had like a 90-minute session on that because I agree with you. That's a technology that's coming, and it's just a question of when.
Well, that's good. That's a good segue because now I had some questions about S4. So let's go down that road now. In 2007, you launched S4, and it's gone from about 35 people event to now it's 3 days on 3 different stages with more than 300 attendees. And I didn't get to go this year. I think Ed and I went. Was it 19 or 20? I think it was right before COVID shut the world down.
I know. Actually, I think you were 19.
Oh, was it? Was it the year before that?
Yeah, I think so.
But
I'm not sure though.
What I do remember is it was we were all looking forward to getting out of Pullman because it was snowy here. We came to Miami and I turned on the news at 11 o'clock and say, watch out for the fallen iguanas because it was so freaking cold in Miami that year. But it is a great event. I was sorry I couldn't go this year, but can you talk about how and why you started S4?
Sure. And by the way, we're up to 800 now.
Oh, my data is out of date. Or you just had a really killer year last year with attendance.
No, it's gone up every year. I think the year you were there, it was like 600 or 700. But we started it out in 2007. I had a researcher, and there was just nowhere to present his paper. There was nowhere that you could present it to an audience of people that understood security and understood the ICS world. So we just said, well, we'll create one where you could provide real technical presentations. And I had some experience in that from the crypto world, because back in the early 90s, the crypto world was just coming out. We had the RSA conference that was so big back in 90 was, Bruce Schneier selling his book out of boxes in the back and Ron Rivest and Shamir and Whit Diffie there doing the rump sessions and that. So we had Whit Diffie as our first keynote to try to say, this is how you build a community. So that's why we started it, really, because we just wanted to get something that, people like us could talk to other people similar.
Well, it's grown, and I know tons of folks from here love to go or wish they could go. Fortunately, they got day jobs, or unfortunately, probably, so they can't always go. But I was watching the tweets this year, and it was like from my perspective, it was a huge event.
One of the things that we've tried to do with it, I mean, it was gory technical. I mean, probably something that you and the SEL crew could really appreciate, because I know you guys put together that event out there, the Western something. I can't remember exactly what it is, but I look at the papers from that, and they're real technical papers. So it was that way. But then, in 2012, 2013, we expanded to some other stages. And I would say our focus right now is really on the creativity side of it. We try to bring top people in the world with a lot of crazy ideas and throw them together. And then we put them in an environment that's very different. There's a lot of art taking place. There's, the parties are around the pool instead of a conference room or convention center or something like that. And just try to take people out of their normal environment and get them to think up new ideas. And it's been really, I guess, good to see that some of those ideas, like the top 20 PLC secure coding practices and ICS for ICS, have gone from these initial sessions to real world ideas.
Yeah, it's a great event. I like to say it's educational and entertaining, all rolled up together, and I think that's what makes for a great conference. How do you see S4 evolving over the next few years?
Well, one of the things we're trying to do is we're trying to bring in more people and more ideas. So we had a women in ICS event this year. We were, like most of the industry, it's about 10 to 12% women in the ICS security world, and it's 50% of the population. So anytime you talk about labor shortages, you're like, well, that's where you can get the big win. If we could get that percentage up to 50%, imagine how many more we would have. So we had 163 women at the event this year, which was still only 20% of the crowd. But, we're trying to bring in more people. I also it was a much younger crowd. So we've got these old timers like myself that have been doing this for decades, but we're trying to bring in new people with new ideas, both into the community and then fields adjacent to the community, get them to provide input. You start to look at insurance and economics and of course the engineering measures when we start to look at the consequence side of the equation. We need to bring more of those people in. So that if I had any goal for the event, it would be to broaden it from the usual suspects that have been coming for years and years and years, and try to get more people with different viewpoints involved.
Well, let me put a plug in for S4. It's a wonderful event. It's entertaining. It's a great time of year to go to Miami and meet a lot of interesting people and learn a lot of stuff about cybersecurity and have a lot of fun, all rolled up into 1 week. It's a great event. I can't say enough about it. Dale, if I had to,
thank you.
Oh, it's great. No, thank you for putting it on. It's fabulous. Let me do the great Karnak, if you will, crystal ball stuff out. If you could look 5 years into the future, what do you think ICS cybersecurity is going to look like? Are we going to be better, more secure? It's going to be more chaos, or what are your predictions?
Oh, boy, I would say, like a lot of progress. And Ed even talked about this when he was on stage. He talks about resets. He said sometimes periodically you need to reset complexity. And when you look at a lot of change across industries, it's not this slow straight line going upwards. And I guess it's as much of a hope as a prediction that we get one of these step functions where all of a sudden things just change. And I think that, this is why I mentioned orchestration. I think once so much of the environments gets virtualized and gets moved around to different places, that then might be the trigger to replace some of these things that had lifetimes that were estimated to be 20 or 30 years. When the benefits get so large in doing it that you just say, well, this makes sense, we're going to do it now. And then it just happens all of a sudden. And my hope, and I think it will happen, 5 years. If you said 3 years, I might be a little skeptical. But I think within that 5-year window, I think we will have one of those events where things just change. I mean, you probably remember, I won't throw vendors under the bus here, but it's not too many years ago, vendors were saying, if you virtualize this server or workstation, you void the warranty. Yeah. Those same vendors 2 years later were saying, we recommend you deploy on this virtual infrastructure. You know, they were actually, their new ones were going out. That was their preferred way of deploying. And so things can actually change quickly if there's a big enough driver. And my hope and my prediction is that driver will come in the next 5 years, and it will be this idea of just being able to be so adaptable and flexible.
You know, I hadn't thought too much about virtualization and what it might drive, but I think you're onto something. If you could virtualize everything that's in a substation as an example, I think you could pull it off. Because right now the challenge is you change one thing, let's call it the cyber, you want to insert some cyber to an existing system. The first thing people are going to tell you what's going to break everything, right? Data. But if you could virtualize everything, test everything out, and then it's really just a matter of sensors, it'd probably be much easier to do an upgrade, say in a substation or an industrial plant floor or something like that. If you could take care of everything because you have virtualized essentially everything.
Yeah. The tricky part with that is, where is the big win that's going to be the business driver? So some of these, the ones that have actually made those step changes, there's a big win. And, you know, your company is founded on one of those big wins. Yeah. And even then, it probably took a little while for that to happen. But I don't know. It's probably a question I should have asked Ed if it was 5 years from the time when he first started deploying these to when everyone said, yes, we need to move to these. But I think there's some time frame like that. If the benefit is big enough, we could see it. And once we make that move, I don't think insecure by design is going to be a choice anymore. Yeah. People are going to say, we're going to make this move. And to make this move, that allows us to make all these changes, we have to embed security in it. And to me, that's where my optimism would be.
That's awesome. Yeah, just a history note on SEL. Ed started the company in 1982. In 1984, he sold the first product. So it was a 2 years of banging on doors and calling people.
But then, do you know what? From 84 to 89, by 89, was everyone pretty much saying, "Yeah, we need to put these things in"? There
were a lot more early adopters at that time. So, well, I mean, just some fun facts. Then is I started in the company in 1994, so 10 years after Ed sold the first product. Just for fun facts, our rate per day, we built 17 relays a day when I started, and now we're well over, we sell thousands of relays every day, right? And so that's the astronomical or exponential growth that's happened. It's been a lot of fun. Yeah. A lot of fun. Dale, thanks so much for spending some time talking cybersecurity for me. And again, let me one more shameless plug for S4. It's a great event. Go out there and go to the S4 conference. And if you're interested in more cybersecurity podcasts, check out Dale Peterson's Unsolicited Response.
Thank you.
All righty. Thanks, Dale.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.